Hello everyone and welcome. As a part of Advanced Machine Learning MOOC course, I am recording this conceptual video on fascinating topic of generative and diffusing models. These models are forefront artificial intelligence enabling us to create manipulation of data in innovative ways. We'll start by dividing the basic of machine learning, understanding how the models learns from data to make prediction on or generate new data. From there, we'll introduce generative models, explaining their core principles and how they can be used to create new data that mirrors the real world example. We'll walk through the mathematical steps and methodology that follows the deeper understanding and how their function of their broad range of the application areas like image and text generation. Then we will focus on the diffusion models, which will have to gain significant attention for their ability to generate high quality data through the process of noise addition and denoising. Then we will break down the mathematical steps of the diffusion models. Then we will understand the application of the diffusion models, and we will also walk through the future advancement of the both generative and the diffusing models. Generative models are powerful branch of machine learning that don't just analyze the data, they create. From generating image to write text, these models learn from underlying pattern in data, can produce entirely new and realistic output. One of the most exciting types of generative models on nowadays is diffusion models. These models works by adding noise to data and then learning to reverse the process gradually, creating new samples that looks like a real data. This approach led the major breakthrough in AI generated. In this video, we'll simplify this concept and walk through how they works and how they are being used. Before diving deeper into the generative models, let's quickly revisit the foundation of machine learning. Machine learning is a branch of artificial intelligence and that enables the system to learn from data and improve the performance without being explicitly programmed for the every task. Instead of hard code programming and hard coding rules, the machine learning algorithm used to find pattern and make the decision or prediction based on what they have learned. One of the most powerful aspects of machine learning is its self-learning capability. As a model is exported for more data, the accuracy and the performance of the machine learning is being improved by the time, almost like a system is learning from the experience. Because of this, machine learning has found of application across a wide range in industry, in healthcare, for disease prediction and personalized treatment plans. In finance sector, it also plays the key role in robotics, entertainment, and the countless of other domains where the automation and data-driven decisions are critical. In short, the machine learning is the engine that drives many of the intelligent systems we'll see around this world in today's scenario. Now that we understood what the machine learning is, let's talk about specific type in generative models. Generative models are designed just not to analyze or classify the data, but it actually create new data. What makes them unique is their ability to underlying pattern and distribution of the data set. Once the data is trained, they can generate the entirely new examples that look like and feels like the original data. For example, if we train a generative model on a thousand of images of human faces, it produces a completely new face that look realistic. These models are being used to many cutting-edge applications. They power image generation tools like Dell, create human-like tests in chatbot, and even used for data augmentation to improve training in other machine learning models. Let's now look at two of the most popular types of generative models, variational encoders and generative adversarial and networks, the common known as GANs. Starting with variational encoders, these models works by compressing the input data in a smaller encoded form and then reconstructing back to its original shape. This process helps the model understand the structure of distribution of data What makes a variational encoder powerful to their use of probabilistic modeling, which allows them to generate new data that is similar but not identical to input. They are especially useful in applications like image generation and anomaly detection. In the other hand, the GAN takes the more competitive approach. They involve two neural network, a generator that creates data and a discriminator that tries to tell whether the data real or fake. These two networks are trained together in a kind of game, consistently improving each other. Over the time, the adversarial training helps the generator produce extreme and realistic outputs, whether it is images, videos, or even music, or even text. Another important category of generative model is autoregressive model. These models generate the data in sequence step by step where each new output depends on the ones before. The sequential dependency is what makes them particularly effective for tasks like speech synthesis and text generation. Some classical example includes autoregressive models like AR and modern deep learning variations such as transformer based models like GPT. So let's break down the mathematical representation which is given below. So basically this equation breaks down in a joint probability in the sequence into products of conditional probabilistic. In simple terms, if I want to explain in simple terms, it means that the model or generate of sequence of data will predict in each item based on the all previous ones. For example, the text generation predicting next word depends on the all words. These models are widely used like areas in natural language processing, time series forecasting, and structured data generation due to their ability to handle sequential data. Autoregressive models work by estimating the conditional probability of each element in sequence based on the element that come before. This allows them to generate coherent and contextually relevant data on one step by step. In this equation, you can see that p of x, the probability of p of x first is generated, then the next probability is multiplication. It will generate the probability of x2 depend on x1, and for the following step it will generate the probability of xn, uh, x of n, uh, on the all respective of x of 1, 2, 3, 4. So this how the mathematical representation will work. So let's now explore the diffusion models. Diffusion model is a type of machine learning model that generates high quality data, especially for the image generation. It creates high quality data by gradually removing noise from a random starting points. You can think like that, starting with a blurry image or static field image and slowly turning into something clear and realistic image. The key idea or the concept of the model first learns how to clean data like real images gets corrupted when the random noise are added into the image. Once it understands the process, it learns how to reverse and step by step removing noise. It will reconstruct the original data. The step by step generation process, it gives the control output, and it increases the quality of our result. This model have been some of the biggest breakthroughs in image generation, and beyond the image generation, diffusing models are now being used for video generation, medical image, and scientific research. So in short, diffusion models are changing the game and what is comes to generating data that looks like and feels like real. Now let's compare two major types of diffusion model based on the generative models. First is DPPM and second is SGM. So DPPM stands for denoising diffusion probabilistic model, and SGM stands for score-based generative models. Starting with their core task, like DPPM are designed to generate high-quality images, videos, and other structured data by learning to gradually remove noise from the input. On the other hand, if we discuss about SGM, it is also produce realistic content, but they go step by step further by generating not just images but also audio and even 3D data. They do this using score function, which estimate the gradients of the data distribution. In terms of execution, DPPM works by learning two processes. The first is a forward process where the noise is added to data, and reverse the process to remove the noise. Both of these are models using deep neural network. In SGM context, it used the stochastic differential equation or the score matching techniques by giving them the more mathematical and flexible approach. Their approach are a little bit different. DPPM use discrete time steps during the denoising, which makes the training slow and computationally expensive. On the other hand, SGM use continuous process to model noise through the ST, which gives the generally makes them more efficient and keep it very adaptive for the generation. As for application, DPPM are commonly used image generation, video generation, as well as medical imaging and for image enhancement. SGM and their border capability are used in 3D model generation, speech and audio synthesis, and high quality image generation. After the discussion of the whole generative models, let's see the real world application of and the use cases. It's widely used in image generation, audio synthesis, scientific application, and other application like video generation, text generation, and chatbot generation, music and audio generation, drug discovery and molecular design, high quality image generation and image enhancement, medical imaging and medical denoising, super resolution and image restoration, 3D object generation, and 3D object design. So these are the widely acceptable application and the use cases of the generative model. So future direction and the challenges of the model, uh, to improve the efficiency, to enhancing the controllability, the medical imaging, drug discovery, and molecular designs. These are the future expect that the whole world will focus on, and the list will go on and on. At the conclusion, I would like to say that the generative models and the variational encoding models learns a pattern from data and creates the similar content. And the diffusing models like DPVM start with the noise and slowly turns into clear and high quality results. Generative models are little bit faster, but sometimes it is unstable, while diffusion models are slower, but it gives the better quality. In the end of the video discussion, I would like to say that the both types of models are important in AI for the task like creating images, discovering new drugs, and building the creative tools. And at the end of the video discussion, I would like to say that each models can retrieve their best output by improving their quality.